Students, today I'm starting the new chapter, that is theories of bonding in metals. Okay, so in this chapter mainly we'll deal with metals and its properties and how the bonding is taking place in the metals. Okay, so before going to theories, let's see what are the metals, where these metals will be present, and what the characteristics the metals will have. Okay, so if you observe the modern periodic table, you can see four different blocks: S, P, D, F. Okay, S consists of completely metals. Okay, B consists of non-metals and metalloids. D consists of transition metals. Okay, F consists of some radioactive metals and inner transition elements. Okay, mainly S and D block elements are metallic in nature. Okay, so in the periodic table, the metals will be present in between in S and D blocks. Okay, so now coming to the properties. Okay, so metals have certain general characteristics. Basing on these characteristics, we can say these substances can be metals. Okay, so firstly, the physical state. Physical state indicates a physical appearance. Already we know many metals exist in the form of solids at room temperature. Okay, so, but there is an exception, that is a mercury, which is a liquid. So, all metals will be solids, but there is an exception, that is a mercury, which is liquid form at the room temperature. Okay. Next, second property is metallic luster. Luster or lustrous property is same. So, what is meant by metallic luster? There are some metals which exhibit shiny property. Okay, their appearance will be shiny in nature. So you can give best examples like silver and gold. Their surface is shiny in nature. And coming to third one, they are hard in nature. Metals are hard. Okay, you can give best example, that is iron. Iron rods, if you take it, is very hard in nature. But there are some some metals which are soft in nature also. Best example we can give sodium. Okay, sodium, when we cut with knife, it will cut into different pieces. So sodium is a soft metal. Okay. Next, coming to conductivity. They are good conductors of heat and electricity also. So coming to the heat conduction, they are good conductors of heat. If I give the example, if we take an iron rod and if you heat at one end, and it supplies that heat to other end also. So that other end also becomes hot. Okay, that means they can conduct heat energy from one side to another side. That is a good conduction of heat. Next, coming to electrical conductions. Electrical conduction is nothing but they are good conductors of electricity also. Okay, best example we can give copper. Copper is used in the form of wire. It is utilized as an electrical conductor. Next, coming to malleability. So malleability means what? Okay, malleability means ability of a metal to form into thin sheets. We can draw some metals into thin sheets. Best example I can give you, aluminium. Aluminium sheets are available in the market, and these sheets are used for food packing and some other packings also. Okay, that means aluminium is the best metal which can be drawn into thin sheets. Next, metals have a property called ductility. So ductility means what? There are some metals which can drawn into thin wires. Okay, so even if you observe the copper is existing in the form of wires and some ornaments also. So metal copper can be drawn into thin wire. Even gold can be drawn into thin wires. Okay, the property of a metal to be drawn into thin wires is called ductility. Okay, next, coming to the melting and boiling points. So the melting and boiling points are very high for the metals. Okay, what is meant by melting point? The point at which the solid gets melt into the liquid is melting point. The point at which the liquid changes into vapor is called boiling point. So both the points will be high for the metals. Okay, next, coming to the alloy formation. Already we have discussed what are the alloys. When two or more metals or one metal or non-metal, when we combine them in their melting form, they'll form a liquid state. So upon cooling again, they'll change into a strong substance, solid, that is alloy. Okay. Best example we can give steel. Steel is a combination of iron along with carbon and molybdenum and some other non-metals also. Okay. Next, coming to electropositivity. So what is meant by electropositivity? The ability of an element to lose electrons is called electropositivity. So if you observe in the modern periodic table, from left to right the size decreases. That means these elements, not these metals, will have a large size when compared to other elements. So because of large size, there will be less nuclear attraction, so that the electrons can be lost from the valence shell easily. So nucleus is not showing more attraction on the valence electrons. So electrons can be easily removed. That property is called electropositivity. So this process, so here metals have low electropositivity. So when there is a more electropositivity, okay, not low, more electropositivity means they readily lose electrons. Next, coming to the next property, they have a low electronegativity. So what is meant by the electronegativity? Ability of an element to attract the shared pair of electrons towards itself. So here if you observe the metal, size will be less, size will be more. But when the element have size less, it has more nuclear attraction and it can attract the electrons towards itself. But here the size is large, so it can't attract the electrons easily. So they have low electronegativity values. Okay. And coming to the last one, they have a low ionization energy. What is meant by ionization energy? The energy required to remove electron from the valence shell is ionization energy. Okay, here we need to apply some energy on the electron to remove electron, because nucleus has attraction on the valence electrons. But when size is more, nucleus shells valence electrons will be far away from the nucleus. So we no need to apply more energy on the electron. Less energy if you apply also, electron will be removed. Okay, so all metals will have a low ionization energy when compared to other non-metals. So non-metals will have a less size, so we need to apply more energy to remove electrons. So they have a more ionization potential or ionization energy. So these are the properties of metals. So the elements which are having these general properties are called metals. Okay.